हेलो स्टूडेंट्स। तो आज हम लोग प्रॉब्लम सॉल्व कर लेते हैं रीमान इंटीग्रेशन के जो प्रॉब्लम्स हैं। सो दैट बेस्ड ऑन दिस, तो डिफरेंट डिफरेंट फंक्शंस को लेकर हम चेक करेंगे उनकी रीमान इंटीग्रेबिलिटी ऑफ द गिवन इंटरवल। ओके, सो लेट्स स्टार्ट विद द फर्स्ट प्रॉब्लम। तो क्वेश्चन नंबर 1। सो लेट्स चेक द इंटीग्रेबिलिटी ऑफ अ कांस्टेंट फंक्शन। तो कांस्टेंट फंक्शन इज ऑलवेज इंटीग्रेबल इन एनी ऑफ द इंटरवल। So let's prove it. So that is your fx is some constant c, where this c is a constant, okay, is integrable r. Integrable r, okay, in any of the interval. Okay, so let's prove this result, this theorem, also this question solution. Okay, so let's prove that constant function is always integrable r. It's Riemann integrable. Okay, so since c is a constant throughout the interval, then its supremum and infimum will be c always in each of the sub interval as well. Okay, so you can just write here, since c constant is constant throughout the interval that is your a comma b, we have for all modes of subintervals. Okay, because value is same in everywhere ना. So जो इनके सब डिविजन्स होंगे, सब इंटरवल्स होंगे, उन सब में इसकी वैल्यू कांस्टेंट सी ही रहेगी। तो इनके जो सुप्रीमम और इन्फीमम हम सब इंटरवल्स के अंदर कंट्रोल करते थे अपर रीमान इंटीग्रल एंड लोअर रीमान इंटीग्रल को कैलकुलेट करने के लिए, तो दैट विल बी सेम इन एवरी इंटरवल। तो दिस इज स्मॉल एम और दिस इज स्मॉल एम आर, or you can say capital MR or capital M, that will be equal to C. तो capital M और small m क्या होते थे? The supremum and infimum of a function throughout the interval a comma b, and small mr is the infimum of the function in the subinterval, this subinterval xr minus 1 up to xr. Okay, and this capital MR is the supremum. So we understood the notations because we have done a lot of things. ओके, तो लेट्स स्टार्ट। तो अब हमें अपर रीमान इंटीग्रल और लोअर रीमान इंटीग्रल को कैलकुलेट करना है। तो कैसे हम उनका एक्सप्रेशन लिखते हैं? देयरफॉर अपर रीमान इंटीग्रल का नोटेशन ऐसे होता है, दैट इज योर एफ एक्स डी एक्स। कैसे डिफाइंड होता है? दैट इज योर लिमिट डेल्टा आर इज टेंडिंग टू जीरो, द समेशन आर इज जस्ट इक्वल टू 1 to n is just equal to capital MR into delta R. Delta R is the length of the subinterval. Okay, so this is equals to this is limit, and this is delta R tending to 0. And because the value MR is C, so this is delta R. So if you are summing all the lengths of the subinterval, you will get B minus A. So this is C times of B minus A. Okay, similarly, if you are going for lower Riemann integral, and this lower Riemann integral, this is fx dx is just equal to, this is limit, this is delta r tending to 0, summation r is equals to 1 to n. This is small mr, where delta r is just equal to, this is limit, delta r is tending to 0, and this is summation of c times of delta r, and this again will be equal to c times b minus a. तो हम लोअर रीमान इंटीग्रल और अपर रीमान इंटीग्रल बोथ आर सेम, so in that case we will say कि this is Riemann integrable. So since you can say since both upper and lower Riemann integrals exist and are equal. So the function, you can say, the function fx is just equal to c is integrable r, is integrable r, and its value is your c times b minus a. Okay, so this is your, so it means the constant function is integrable, Riemann integrable. Okay, नेक्स्ट क्वेश्चन की तरफ बढ़ते हैं. नेक्स्ट प्रॉब्लम, क्वेश्चन नंबर 2. So examine, we have to check the Riemann integrability of the function. The Riemann integrability or otherwise it is integrable or not of the function fx, where the function is defined in this way. This is fx is just equal to is 0 when x is rational, and it will be 1 when x is irrational. सो इट इज क्लियर, हम कोई भी सब इंटरवल क्यों ना ले ले, उसमें इनफाइनाइट नंबर ऑफ रेशनल और इनफाइनाइट नंबर ऑफ इरेशनल वैल्यूज होती हैं एक्स की. तो इट मींस इन्फिमम, सबसे लोएस्ट वैल्यू जो होगी वो 0 आ जाएगी और सबसे ग्रेटेस्ट वैल्यू होगी वो 1 आ जाएगी. तो इसका मतलब एवरी सब इंटरवल के अंदर जो इन्फिमम होगा दैट विल बी 0 एंड जो सुप्रीमम होगा दैट विल बी 1. अगर हम थ्रू आउट द इंटरवल बात करें, थ्रू आउट द इंटरवल ए कमा बी हम बात करें, तो उसके अंदर भी हमारे पास फंक्शन की वैल्यू जो सुप्रीमम होगा दैट विल बी 1 और जो इन्फिमम होगा वो 0 होगा. तो इज इट क्लियर? ओके, तो हेयर इंटरवल इज 1 a comma b. Is a closed interval a comma b. Okay, so let's write the solution. Let us check it is integrable r or not. So I'm just dividing this subinterval. So let the interval this a comma b be divided into a number of subintervals that is your xr minus 1 up to xr, where this is r equals to 1 2 3 up to n in any manner. है ना, कोई भी हम सब इंटरवल बना सकते हैं, है ना, कोई भी हम पार्टीशन ले सकते हैं और क्लोज इंटरवल ए कमा बी का. और यू कैन क्लियरली सी दैट infimum will be 0 and the supremum will be 1 in each of the sub interval. So you can also write, so we can able to, so each of these sub intervals of these subintervals contains some rational and some irrational. Some irrational points. Okay, is it clear? है ना? There are infinitely number of some की तो infinitely number of rational and irrational any of the interval which is non-empty. Okay, so therefore you can say in each of the case, उसको लैंग्वेज में थोड़ा सा लिख लेते हैं तो आपके पास रिटन इंफॉर्मेशन रहेगी. सब इंटरवल्स, any of the interval you can just taking xr minus 1 or xr. Okay, the value of upper bound will be 1. तो इसको हम इस कैपिटल एम आर बोलते हैं, दैट इज योर 1, while the value of the lower bound will be 0. While the value of the lower bound, this is small mr, is just equal to 0. So consequently we can say this integration from a to b, it means upper Riemann integration कि अगर वैल्यू हम कैलकुलेट करने जाएंगे तो दैट इज इक्वल टू लिमिट डेल्टा r is tending to 0. This is summation r is equals to 1 to n mr into delta r. Okay, so mr is constant, that is your 1. So this is your limit delta r is tending to 0. This is summation r is equals to 1 to n. This is 1 into delta. So if you are summing out all these subintervals length, you will get the whole length of the interval a to b. So it will be equal to b minus a. Okay, so this value will be equal to b minus a. Okay, what will be the lower Riemann integration? Let us see. That will be 0 because the infimum is 0 in all the subintervals. Okay, so this is your a b, that is your fx dx is just equal to, this is limit of delta r tending to 0. This is summation r is equals to 1 to n, and this is small mr into delta r is just equal to, this is limit delta r is tending to 0. This is summation r is equals to 1 to n into 0 into delta, because जो इन्फिमम है सब इंटरवल्स के अंदर वो सारा कितना है, 0 है. तो दिस होल वैल्यू विल बी इक्वल टू, तो 0, दिस इज 0 इंटू बी माइनस ए, तो इट बिकम्स 0. तो वी क्लियरली सी कि जो हमारे पास अपर रीमान इंटीग्रेशन है वो बी माइनस ए आ रहा है, और जो लोअर रीमान इंटीग्रेशन है वो 0 आ रहा है. तो बोथ आर नॉट इक्वल. इट मीन दिस फंक्शन which giving the value 0 for x is rational and 1 for x is irrational is not integrable r. It is not integrable r. So you can just say here, since the values of the upper and lower Riemann integrals are not equal, the function is not integrable r. Okay, it's not Riemann integrable. Okay, so this is a solution for the question. if fx is 0 when x is rational, and 1 if x is irrational. Okay. Let's take another function which is same as above. Question number third. So if fx is defined in this way, that is equals to root of 1 minus x square. X is rational. It is rational. When it is rational, I'm just taking this, and it will be 1 minus x when x is irrational. When x is irrational. Okay, so this is defined, and they are asking about so that first, that lower Riemann integration from 0 to 1 interval ले रहे हैं, the interval taking 0 to 1. This is fx dx is just equal to 1 by 2, and if you are calculating the upper Riemann integration, so this will be equal to 1 by 4 of pi, and thus you can clearly say this function is not integrable. R is not integrable. So we have to find the lower Riemann integration and upper Riemann integration. Okay, so this is actually upper Riemann integration. Okay, so let's find a solution of simply. So here one thing is notice, we are taking x from the interval, close interval 0 comma 1. Okay, and one thing is very important to know, that x square, if you any value, if you are taking any value between 0 and 1, any value between 0 and 1, and you are squaring, to this value will be less than x. Okay, this value will be lesser than 2x. Okay, so in the behalf of this thing, you just clearly say, okay, so in the interval in interval 0 1, you clearly say, so if x square is less than x, okay, then 1 minus x square will be greater than 1 minus x. Okay, so this will be root of 1 minus x square will be greater than 1 minus x. Okay, so throughout this interval, you can easily able to find. So you are breaking in the sub interval, so this value will be maximum. Okay, it means it gives the supremum. This function gives the value of supremum, and this function gives the value of infimum. Okay, you just clear about it. Okay, so first we are calculating the lower Riemann integral. So hence I, that is equals to integration from 0, lower Riemann integration 0 to 1, and this is your fx dx. So in this interval we have to take fx is 1 minus x, because we are taking the lower value. So we will have to check which function is more and less. So if you are going to in throughout the interval, whatever, so this function fx will be taken 1 minus x. So you just calculate 1 minus x here. Okay, and now you just integrate. So this will be x minus x square upon 2, and you are just putting the value 0 to 1. So this is 1 minus 1 by 2 minus 0, and it will be equal to 1 by 2. So it is clear that lower Riemann integral is 1 by 2. So this implies, you can easily say, the lower Riemann integration of fx dx is just equal to 1 by 2. So this first answer we got. Next, we have to find the upper Riemann integral. So for the upper Riemann integration for the j, this 0 to 1 bar of fx dx, we have to take the maximum value of the function or you can say supremum value of the function, and the supremum value is given by this function. Okay, so we have to take 0 to 1, and in the place of fx we have to put this is 1 minus x square of dx. Now you just apply the formula of integration. So what is the integration formula? 1 upon x root of 1 minus x square, and plus this is 1 by 2 sine inverse of x. Okay, and now you just apply the limit in this. So when you are applying limit, when you putting 1, it will become the term 0, and it will be 1 by 2, and this is sine inverse of 1. Okay, when you putting 0, both the terms will be 0. So this will all terms will be equal to 0. So this is 1 by 2, and sine inverse 1 की value क्या होती है? Pi by 2, because sine pi by 2 is just equal to 1. Okay, sine pi by 2 is just equal to 1. Okay, so this is equals to pi upon 4. So we will get the upper Riemann integration. So this implies this is 0 to 1 of fx dx is just equal to pi upon 4. ओके, सो दूसरा आंसर आ गया, क्योंकि दोनों इक्वल नहीं है तो दिस implies they are not integrable r. So you clearly see, since you can say, since this is I is not equals to j, so the function fx is not integrable. Got it? So this is the way to solve the problems. Okay. In the same manner, we have another problem. So let us see. Example number 4, equation 4. Okay, so question 4 is what? This is calculate the values of upper and lower Riemann integration integrals for the function fx, which is defined in the interval interval 0 to 2. Okay, as follows. Okay, so we have this fx is defined like this. So given two functions, one is x plus x square when x is rational, and this is your x square plus x cube when x is irrational. Okay, so these are two functions given for the rational and irrational. तो अपर एंड लोअर रीमान इंटीग्रल्स हमें फाइंड करना है. ओके, एंड देन we'll have to check they are Riemann integrable or not. Okay, so solution. तो पहले हमें तो ये देखना होगा कि हमारे पास जो फंक्शन है कब मैक्सिमम वैल्यू दे रहा है, कब मिनिमम. तो अगर हम इंटरवल 0 से 1 लेते हैं तो हम जितना पावर रेज करते जाएंगे उसकी वैल्यू कम होती चली जाएगी. ये ऑलवेज आप ध्यान रखिएगा, यदि x की पावर k plus 1 is always greater than x power k if k is some positive number, if some is some positive number, some integer you can say. Okay, it is some positive number. Okay, so ye if you are taking x in this interval 0 to 1, if beyond this अगर हम x not is in the interval 0 comma 1 and it is lesser or greater whatever, So in that case, if you are taking some x which is greater than 1, so in that case this x power k plus 1, sorry, here it will be lesser than, this will be greater than x की पावर k. ओके, सो ये चीज आपको ध्यान रखना है. So let us try to check ki which function is gives maximum value or minimum. Okay, so we divide the given interval because here we take the interval 0 to 2. So we just divide in two intervals. I'm just in 0 to 1 and 1 to 2. I'm dividing in two intervals. Okay, so we divide the given interval into two parts. One is 0 to 1 and another is 1 to 2. Okay, so if you are talking about the interval 0 to 1, the function x plus x square will be greater than x square plus x cube. Okay, and if you are you talking about the second subpart 1 to 2, okay, this x plus x square will be lesser than 2x square plus x cube. So according to that, we are going to find the upper Riemann integration and lower Riemann integration. So consequently, that the upper Riemann integration, that is 0 to 2 bar, okay, of fx dx. I am just taking the break from 0 to 1 fx dx. इसका हम अपर रीमान इंटीग्रेशन कैलकुलेट करते हैं, एंड 1 to 2 के अंदर भी हम अपर रीमान इंटीग्रेशन कैलकुलेट करते हैं. तो हमें बेसिकली हमें सुप्रीमम या मैक्सिमम वैल्यू जो फंक्शन दे रहा होता है उस फंक्शन को लेना होता है. तो इसके अंदर जो फंक्शन हम लेंगे फ्रॉम 0 to 1, दैट विल बी एक्स प्लस एक्स स्क्वायर. ओके, एंड फ्रॉम 1 to 2 जो हम फंक्शन लेंगे दैट इज योर एक्स स्क्वायर प्लस एक्स क्यूब ऑफ dx. Got it? So from here you can easily see this is your x square plus upon 2, and this is x cube upon 3. This is limit 0 to 1, and plus this is x cube upon 3 plus x power 4 upon 4. This is in the limit 1 to 2. Clear? तो इसको थोड़ा सिंप्लीफाई करते हैं, और सिंप्लीफाई करने के बाद दिस विल बी 1/2 प्लस 1/3. तो ये हो गया, एंड बाकी तो जीरो रहेगा, एंड प्लस दिस इज 2. तो ये हो जाएगा 2 to the power 2 is 8, 8/3 प्लस this is your 16 upon 4. ये हो गया, एंड माइनस दिस इज योर 1/3 प्लस 1/4. Okay, so let's simplify it easily. This is your 3 to the 6, so 3 to 5. So this is 5.6, 5/6, plus this is uh, mm, 4 3 is 12. I'm taking the 12 as a 12. Okay, so 4 3 is 12. So uh, 8 4 is 32. तो ये हो जाएगा 32 प्लस 16 48. Okay, 38, and minus this is 4 and this 7/12. So क्या मिलेगा, let us see. So this is 5.6 प्लस इनको हम जब सब्ट्रैक्ट करेंगे इन दोनों में सेम बेस है तो इट विल बी 12, और 41. अगर हम 48 में से 7 सब्ट्रैक्ट करते हैं तो 41 प्लस 32, it will be 73. Here will be 73. Okay, so will be 70. तो इफ यू आर टेकिंग 12 एज अ, तो यहाँ पर 10 हो जाएगा, 10 प्लस 73, तो इट विल बी इक्वल्स टू 83 upon 12. This is your answer. So this is upper Riemann integration, 0 to 2 bar of fx dx. So similarly, we can able to calculate the lower Riemann integration. Let us see the lower Riemann integration क्या आता है. So while we are going to calculate the lower Riemann integration I, which is from 0 to of fx dx. तो नाउ मिनिमम वैल्यू इसको भी ब्रेक करते हैं 0 to 1 fx dx and plus I'm just 1 bar to 2 of fx dx. तो जो मिनिमम वैल्यू दे रहा है वो उस फंक्शन को लेना है. तो 0 to 1 के बीच में जो मिनिमम दे रहा है वो 0 to 1 एंड दैट इज योर एक्स स्क्वायर प्लस एक्स क्यूब ऑफ dx. एंड जो 1 से 2 के बीच में मिनिमम दे रहा है दैट इज योर एक्स प्लस एक्स स्क्वायर dx. ओके, एंड बाय दिस you have x cube upon 3 plus x power 4 upon 4. This is 0 to 1 interval, and this is x square upon 2 plus x cube upon 3. This is from 1 to 2 interval. So this is 1 by 3 plus 1 upon 4. ये आ गया, and plus यहाँ पर 2 रखेंगे, so 2 दूनी 4. तो this is 4 upon 2 plus 8 upon 3. ये हो गया, और माइनस का दिस इज 1 by 2 एंड प्लस 1 by 3. ओके, तो दिस इज 1 upon 12, 7 upon 12. ये हो गया, और प्लस दिस इज योर 6, 3 to the 6. तो दिस इज 12 प्लस 16, 16 है ना, 4 3 12 एंड 16. और ये माइनस जब इसमें ले लेंगे तो दैट इज योर 5 upon 6. Okay, so this is 7 upon 12 plus 11 and 11. 16 में से 5 गए तो 11 बचे, 11 और 12 23, 23 upon 6. तो यहाँ पर ले लेते हैं हम एलसीएम. कितना हो जाएगा एलसीएम? 12. ओके, तो इसमें मल्टीप्लाई करते तो 7 प्लस 46 46. तो 46 ये हो जाएगा 3 और 5. तो यहाँ पर आ जाएगा आंसर 53 अपॉन 12. सो जो लोअर रीमान इंटीग्रेशन है दैट इज 0 to 2 ऑफ एफ एक्स डी एक्स इज जस्ट इक्वल टू 53 अपॉन 12. बट बोथ आर नॉट इक्वल. इसका मतलब फंक्शन इज नॉट रीमान इंटीग्रेबल. तो दिस इंप्लाइज फंक्शन इज नॉट इंटीग्रेबल आर. ओके, सो एक ये आंसर आपका हो गया. गॉट इट? आइए एक और प्रॉब्लम करते हैं, दैट क्वेश्चन नंबर 5. तो क्वेश्चन नंबर 5, क्वेश्चन 5. ओके, so that the function defined as fx is just equal to 0 when x is an integer. An integer and it will be 1 otherwise. तो अगर x इंटीजर है तो उसके लिए इसकी वैल्यू 0 है, अदरवाइज इट इज 1. ओके, सो इज इंटीग्रेबल आर. इट इज इंटीग्रेबल आर. तो इसको बड़ा सावधानी पूर्वक हमें प्रूव करना होगा. ओके, इन द इंटरवल the interval 0 to n कोई भी इंटीजर है, where n is an integer, where n is an integer. Okay, where n is an integer. So we will break all the intervals and very carefully we will prove this result. Okay, this question. Okay, and it's very nice problem actually. So that the function fx equals to 0 when x is an integer and otherwise it is 1 is integrable r. This in this interval 0 to n, it means 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5, एनी इंटरवल अगर हम ले रहे हैं तो इन सारे इंटरवल्स के अंदर ये फंक्शन हमारे पास इंटीग्रेबल आ रहे हैं. इट मींस इस गिव द Riemann integration value, है ना, it gives the Riemann integration value. So let's start doing this solution. Okay, so proof of this question or result. So the points of discontinuities of the function in the interval are the values where the integer is there. वही इंटीग्रल पॉइंट पे फंक्शन डिसकंटिन्यूस शो करेगा क्योंकि वहीं पर फंक्शन की वैल्यू बदल रही है. इनके अदर और किसी पॉइंट पे फंक्शन की वैल्यू सेम ही 1 ही रह रही है. तो दैट इन दैट वे इट इज कॉन्टिन्यूस इन द पॉइंट. ओके, अगर हम इस अगर हम इसकी बात करें, इसके ग्राफ की अगर हम बात करें, सपोज दैट वी वांट टू ड्रॉ द ग्राफ ऑफ दिस फंक्शन. So this is your, suppose that this is your x-axis and uh, 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 it's, if this is your suppose that 1, this is 0, this is your 2, 3, 4, 5, ये सारे इंटीग्रल पॉइंट्स है, -1, -2, -3. तो इस फंक्शन को अगर हम ड्रॉ करना चाहें तो व्हेन x बराबर 0 तो फंक्शन की वैल्यू क्या है, 0, मतलब ये, और ये हो गया 1, ये आपका फंक्शन की वैल्यू वाला 1. when function between 0 and 1, so here you will have a circle and from here to it will be circle, it gives here this value, फिर इस यहाँ से यहाँ तक का सर्कल, फिर यहाँ पर एक पॉइंट की वैल्यू. इस तरीके से फंक्शन तो डिसकंटिन्यूटी जो शो कर रहा है वो ओनली और इंटीग्रल पॉइंट्स पे शो कर रहा है. ओके, तो दिस इज हैव डिसकंटिन्यूटीज ओनली ऑन द इंटीग्रल पॉइंट्स. ओके, एंड सो ऑन. So let's start. So just write here the points of discontinuities of discontinuities discontinuities of the function in the interval in the interval 0 to n are given by that is x equals to all the integral points 0, 1, 2, 3 up to n, which are the infinite. ओके, जो कि फाइनाइट है इन नंबर्स में, और फाइनाइट में अगर होता है तो वो इंटीग्रेबल, वो फंक्शन हमारा इंटीग्रेबल होता है ना. ये चीज हमने एक रिजल्ट में पढ़ी थी. So and we can able to enclose each and the discontinuity in a interval which is very less length. Okay, so be enclose each of these discontinuities discontinuous points in some intervals of length is very less. Okay, that is your epsilon by n. Okay, you can able to, where this is epsilon, where epsilon is n, arbitrary small positive number. Okay, So since total length of the subintervals containing the points of discontinuity is less than epsilon, so क्योंकि हमारे हर एक इंटरवल की लेंथ epsilon पॉइंट n है, so अगर हम इनको सम अप करते हैं तो that total length will be lesser than epsilon. So since you can just have the total length of these subintervals intervals containing the points of discontinuities is less than epsilon. Okay, so the given function is integrable R. Is integrable R. So to find the value of the integral we divide the interval in the subintervals interval 0 to n into n subparts like this. This is r plus delta and this is r plus 1 minus delta. Okay, where r is just equal to 0, 1, 2, 3 up to n minus 1. Okay, and we can find the integration in each of the intervals. Okay, so in each of the interval, and each of these subintervals the value of the function fx is just equal to 1. So hence integration, this is from 0 to n of fx dx is just equal to summation. This is r equals to 0 to n minus 1. This is your r plus delta and this is r plus 1 minus delta of fx dx. क्योंकि हर एक इंटरवल के अंदर सब इंटरवल के अंदर इसकी वैल्यू 1 है फंक्शन की, बिकॉज केवल और केवल इंटीग्रल पॉइंट्स पे उसकी वैल्यू 0 है, अदरवाइज इसकी वैल्यू क्या है 1 है. तो उस केस में यू विल गेट दिस इज समेशन r इज इक्वल टू 1 to n minus 1 and this is from r plus delta and this is r plus 1 minus delta or this is 1 into dx. So this implies it gives summation r is equals to 0 to n minus 1 and that is your r plus 1 minus delta and that is equals to summation r is equals to 0 to n minus 1 and this is 1 minus 2 delta. Okay, and that will be equal to your n into 1 minus 2 delta and that is equals to n. As you can say this delta is tending to 0. So जो इंटीग्रल का वैल्यू आएगा that will be n. So you can say 0 to n of fx dx that will be integrable r and the value of the function will be equal to n. The value of the integral will be equal to n if the limit is from 0 to n. Okay, so this is the solution for the function. So here, because the points of discontinuities are finite, So we can break the interval in the sub-interval, in the parts, okay? And we are not talking about the points, integral points. And we are only talking about the between the integral 0 to 1, 1 to 2, 2, 3, and so on. And each of the sub-intervals, it will be integrable r. So it will be integrable r over through the through whole interval 0 to n. So this is the concept or theorem behind it. So ये एक हमने रिजल्ट प्रूफ देखा था ड्यूरिंग द इंटीग्रेबिलिटी. तो फ्रॉम दैट वी कैन एबल टू से दिस फंक्शन fx it will be 0 when x is integer and 1 when otherwise the integer. So it will be integrable r throughout the interval 0 to n. So you just remember this result. It is very very important as a result. You can also remember this question as a result. Okay. Let's next let's solve one more question, that is question number 6. So that the function so that the function fx is just equal to 1 upon 2 to the power n when this is 1 upon 2 to the power n plus 1 is less than x is less or equal to 1 upon 2 to the power n, where n is just equal to 0, 1, 2, and so on, is just equal to 0 when this is x is equals to 3. Each integrable r in the closed interval 0 to 1, okay, and find its value. Okay, so this is function fx is 1 upon 2 to the power n, okay, when this x lies between these two values in that case. So let's prove. Uh, Okay, so we'll have to write some concept so we can able to recall all the things. So the function has an infinite number of points of discontinuities here. Okay, because when x is 0, so because interval is from 1 by 2 plus 1 to 2, so here we can have the different points. Okay, so let's start writing. So the number of discontinuity is infinite. Okay, so the function has an infinite number of points of discontinuity. At the points when where n is just equal to 1, 2, 3, and so. ओके, तो एन 1 2 3 तरीके से कर लेंगे तो हर एक जब रखेंगे तो उसमें हमारे पास इनफाइनाइट नंबर ऑफ डिसकंटिन्यूटी, हर एक इंटरवल के अंदर एक डिसकंटिन्यूटी कंटिन्यू. तो वी इनक्लोज ऑल दीज पॉइंट इन डिसकंटिन्यूटी सब इंटरवल ऑफ लेंथ. So let's enclose and find the sum of the length of each subintervals. If it is less than epsilon, then we can able to say it is integrable R. Okay. So B enclose all these points of discontinuities in subinterval of length that is of epsilon by 2, epsilon power 2 का square, epsilon upon 3 का cube, and so on. The total length of these subintervals is, तो अगर हम इनको आप एड अप करेंगे तो दैट विल बी 1/2 and 1/2 in so on, and that will be equal to epsilon. So this is your epsilon upon 2 plus epsilon upon 2 square plus 1 upon epsilon upon 2 का cube, 3 का cube, and so on. So that will be equal to epsilon. So we can say this is bounded, so it will be integrable over R. So the function is bounded. The function being bounded in integration 0 to 1 is therefore integrable R. So to find the value of the integral we divide the interval in subintervals, okay, 0 to 1, in this way. Okay, this is your 1/2 plus delta 1, एक तो ये इंटरवल हो गया. Similarly 1/4 plus delta, this is 1/2, and this is 1/8 plus delta, and that is 1/4, and so on. Where this is ultimately this delta is tending to 0. So what we get from here, consequently, we have integration from 0 to 1 of fx dx is just equal to 1/2 plus delta is 1 of fx dx plus integration 1/4 plus delta, and that is your 1/2 of fx dx, and plus this is integration, this is 1/8 plus delta, that is your 1/4 of fx dx. So that is equals to integration, this is 1, this is 1/2 plus delta, यहाँ पर 1 आ जाएगा, and in similar way this is 1/2 आ जाएगा, 1/4 plus delta and 1/2, ये वहाँ पर 1/2 आ जाएगा, and इस तरीके से जितने भी सब इंटरवल्स होंगे 1/8 plus delta to 1/4, इसमें 1/4 आ जाएगा, and if you are going to simplify, so you will able to find क्या आ जाएगा, this is your 1 minus 1/2 plus delta, and plus this is your 1/2, and this is 1/2 minus 1/4 plus delta, and 1/4, and this is bracket में 1/4 minus this is 1/8 plus delta, and so on. So from here you will get 1/2 minus delta, and this is you get 1/2, this is 1/4 minus delta, and plus this is 1/4 is 1/8 minus delta, and so on. So if you are going to find the values, so तो here you will have 1/2, फिर यहाँ पर जब मल्टीप्लाई करेंगे तो ये हो जाएगा 2 की क्यू पावर क्यूब, यहाँ जब मल्टीप्लाई करेंगे 2 की पावर 5, ये आ जाएगा एक, तो एक ब्रैकेट में, दूसरा आ जाएगा माइनस डेल्टा, एंड वी आर मल्टीप्लाइंग दिस इज डेल्टा एंड दिस इज योर प्लस 1/2 of delta plus 1.4 of delta and so on. Okay, and from here you will get this is sum is 2 upon 3, and it sum is delta, so it will be tending to 2 upon 3, as if delta is tending to 0. So the integral value will becomes equals to 0 to 1 of fx dx is just equal to 2 upon 3. So this is your answer. Okay, so these are examples solution, and I hope you understood how we are solving the problems. It may be somewhere is calculation error, but it is the conceptual things. So you should know how we will solve. तो next exercise में हम कुछ और problem solve कर देंगे, and then we will move in the next chapter. Okay, so we will meet in the next lecture. Thank you so much for watching and keep learning from here. Thank you so much.